Hello everyone! So today we are going to talk about the distributive property and how we can use it to simplify expressions. Our learning target for the day in this particular lesson is to apply properties of operations as strategies to add, subtract, factor, and expand linear expressions with rational coefficients. So by the end of this lesson, you will be able to define and accurately apply the distributive property to a given expression. And using this distributive property will help in our future lessons, like when we go into solving multi-step equations. But right now we are just focusing on the fact of expanding our expressions and combining like terms. And combining like terms should be a little bit of a review for you, but we'll still go over it. This is the process of combining terms with similar exponents. An example would be negative 6k plus 7k. We see here that they both have a k to the power of 1 in common, so we're able to combine these two numbers into just one number. So it would be negative 6k plus 7k would equal just 1k. Next we have n minus 4 minus 9. The negative 4 and negative 9 are coefficients as they can be combined into one number. So negative 4 minus 9 would be 13, and n does not have any similar terms. So our answer just simplifies to n minus 13. As a helpful reminder, it is important to be careful with your signs and keep the correct ones connected to the right variable. We don't want to accidentally leave out a negative and accidentally leave out a positive, because then our answers will not be correct. So moving forward, this is the distributive property. The distributive property is when we multiply a sum by multiplying each variable or number separately, and then we add its products. Now this kind of sounds a little confusing, but just hang with me as I explain this process. We have 3 times the quantity of 8 plus 5. Now when we see this, you might automatically be like, oh, I could totally do this. This is so easy. But I'm going to show you a different method. Instead of just adding inside the parentheses 8 plus 5 and multiplying by 3 to get 39, I want to show you a different process. So, as we take this equation, we are using the distributive property, which is multiplying the variables separately. So we're taking each number as a separate variable. We want to take the 3 and multiply it by the 8. And we want to take the 3 and multiply it by the 5. So our equation now looks like this. 3 times 8 plus 3 times 5. We can simplify this by multiplying 3 times 8 to equal 24 and 3 times 5 to equal 15. We are not quite done in this situation, as we have two coefficients that could easily be combined to equal 39. It's very important in these certain situations that we remember PEMDAS and the order of operations to make sure that we're solving the equation correctly. Now we're adding variables. So like I said in the previous slide, the process is what matters, not necessarily how you would solve it. So the process is we're taking 4 and multiplying it by x. We're taking 4 and multiplying it by 7. When we simplify this, it just turns out to be 4x plus 28. There are no variables in this that can be simplified, so our answer is just 4x plus 28. 5 times the quantity of x minus 2. This can be defined in the same process as we have been going through. We take 5, multiply it by x, and we add it to 5 multiplied by negative 2. This is where it's important to keep your negatives with the right numbers. When we simplify this, we get 5x minus 10. Here we also see that there are no common numbers with the same exponents. So our answer is just 5x minus 10. Now I want you to try to complete this problem on your own. It is in your guided notes. So the problem is negative 2n minus 1 times the quantity 9 minus 10n. You may pause the video if you need to have a little bit more time. Here's the solution. The answer is 8n minus 9. How did I get this? Well, some of you might have got tripped up by the negative 2n on the outside. That is not what we're multiplying the quantity by. We're multiplying the quantity by negative 1. So the negative 2n just stays where it is, does not get multiplied by anything. But we have to add what the quantity is being multiplied by. So we'll do negative 1 times the quantity of 9 minus 10n, which is negative 1 times 9 plus negative 1 times negative 10n. When we simplify that, we get negative 2n minus 9 plus 10n. In this last expression, we see that there are two numbers with the same coefficients, so we're able to combine those terms of negative 2n and positive 10n to get 8n, and there's nothing that can be combined to negative 9, so it just is left as negative 9. So our answer is 8n minus 9. A little bit of a challenge to this is we're going to show double distributive property, which is performing the distributive property to two different sets. And what I mean by that is this example below. So we want to multiply 5 times the quantity of negative 2n plus 4 plus 2 times the quantity of n plus 3. I like to create two sets when I'm thinking of this to simplify the problem a little bit. So for set 1, you'll have 5 times negative 2n plus 4. In set 2, you'll have 2 times n plus 3. Now, this simplifies the expression a little bit and makes the problem a little more bearable. So for set 1, we had 5 times the quantity of negative 2n plus 4. We do the same technique that we've been doing throughout this whole lesson. You take 5 times negative 2n and 5 times 4. When you simplify that, you get negative 10n plus 20. Set 2 is the same way. You take 2 times n plus 3, the quantity n plus 3, and you take 2 times n plus 2 times 3, and simplify that to get 2n plus 6. If it's easier to learn this process, I sometimes draw an arrow from 5 to the first number and 5 from the second number, so you're able to see that you have to multiply 5 to both terms, not just one. It is important to know that fact. So since we split the example into two sets, we have to combine it back into one because that's how it was written. So we'll take the set 1 plus the set 2. So it'll turn out to be negative 10n plus 20 plus the quantity of 2n plus 6. And since we're adding it does not change the signs of the second quantity, so it'll just be negative 10n plus 20 plus 2n plus 6. There's multiple different like terms in this situation, so once we simplify that and find which exponents have the same, we solve the equation by figuring out that it's negative 8n plus 26. And there we have it. So this is how the distributive property works. This property is a building block to many new properties that we will continue to learn, and this property it never goes away. So it's one of those that we need to make sure that we know to our best knowledge, and we continuously practice it and make sure we have it down. So now it's a little bit of game time. So attached to this lecture, I provided a distributive property battleship game. So this is a way for you to practice your skills on this newly learned topic, and a fun interactive way to continue learning and practicing. So thank you for listening and learning about the distributive property.